You've recently stated that NASA is maybe concealing the truth about 3 Atlas. NASA did release images in the past, but the best image is yet to come. It was obtained on October 2nd when the object was 30 million kilometers away from Mars, and the high-rise camera on board the Mars Reconnaissance Orbiter took the very sharpest image of it, and we really want to see that image. However, the claim is that because of the government shutdown, we are not able to see it. It started with silence, not the quiet of space but the kind of silence that follows when a live feed goes dark. Inside NASA's Deep Space Tracking Network, one of the main data relays stopped transmitting. Engineers were midship when the console froze, its signal light fading from green to red. Within minutes, the feed for one of NASA's most important asteroid detection eyes, the NEOS infrared telescope, went completely offline. At first it looked like a routine glitch. Satellites drop out all the time. But this time, the shutdown happened exactly 48 hours after an alert had been logged for something unusual. A fast, dim object that cut across Earth's orbital path, moving in a way that didn't fit any known trajectory. The system flagged it, cataloged it, and then nothing. The network went silent. That was the moment social media lit up. Space enthusiasts noticed the sudden absence in NEO's publicly available data feed. Amateur trackers saw missing telemetry lines. Within hours, forums exploded. Was NASA hiding a detection? Was this an impact threat or something they couldn't identify? NASA gave no immediate statement, no tweet, no press update, just a quiet note that NEOS was entering standby mode. But anyone familiar with how NASA operates knew that didn't make sense. This wasn't how planned maintenance was handled. It felt abrupt, voice low, almost whispering to the viewer. NASA shuts down its asteroid detection system right after spotting something it's never seen before. Coincidence? Or did they find something they weren't ready to face? In less than a minute, a pattern begins to emerge, one that raises a question bigger than any headline. What could force the world's most advanced asteroid detection program to go dark at the exact moment it detected something that shouldn't be there? So, what really happened inside NASA's Asteroid Command Center that night? Imagine the scene: mission control bathed in the dim blue glow of monitors, the hum of servers, the kind of tension that makes every keystroke feel heavier than usual. Was this just a technical failure, a scheduled shutdown no one outside the loop understood? Or did the agency quietly hit the brakes on something much bigger, something it didn't want the world to see yet? Look, NASA doesn't just flip a switch and walk away from a billion-dollar surveillance asset. There's a process, a countdown, a series of public logs that always follow. But this time there was none of that. Just an official note saying NEOS had entered standby mode, and then radio silence. Let's dig into what we actually know and what might be unfolding behind the scenes, because right now, something about this timing doesn't add up. Just days before NEOS went dark, something strange showed up on NASA's deep space radar. An interstellar object officially named 3I divided by Atlas appeared out of nowhere, cutting through the solar system on a path no one had predicted. It wasn't from here. It wasn't behaving like anything that should exist. When scientists analyzed its light signature, what they found didn't make sense. The chemical spectrum showed nickel and cyanide, but no trace of iron. That's like finding a car engine made entirely of chrome, shiny, metallic, but missing the one material that's supposed to hold everything together. NASA's own analysts reportedly called the readings an outlier. No one could explain how an object like that could form naturally. Here's where it gets even stranger. Within 36 hours of those readings hitting NASA's servers, NEOS, the same telescope responsible for identifying the anomaly, stopped transmitting. The data stream froze. No warning, no press release, just silence. And then, officially, the mission was declared over. What if that final observation didn't just reveal another comet, but something that looked manufactured? Because nickel without iron shouldn't happen in nature. But in engineering, that's the kind of metal ratio you'd find in electroplating, spacecraft alloys, even advanced thermal shielding. So here's the question that no one inside NASA seems eager to answer. Was this object a natural wanderer from another star system, or something sent? Before we go deeper, hit subscribe because what comes next might change how you think about NASA's asteroid program forever. Officially, NEOS shutdown in 2024 was planned. NASA called it a graceful end to a legendary mission. The telescope had exceeded its lifespan, and increasing atmospheric drag made its orbit unstable. The final mission log simply read, "Signal decay detected. Transmission terminated." But behind that clean, clinical language sits a detail that was never publicized. Several engineers, people who worked on the mission, later noted that data packets were still being received for hours after the official deactivation. The transmitter was supposedly off, but the system kept whispering, small, fragmented bursts of information still flowing into restricted servers. NASA never mentioned that in the press briefings. The agency framed the shutdown as routine. But if those final scans contained anything unusual, say spectral data from 3 divided by Atlas or another unidentified object, it raises a quiet, uncomfortable question. Where did that information go? Could NASA have redirected those final scans to a classified channel, one not accessible to public archives or university researchers? It wouldn't be unprecedented. The agency already partners with defense agencies during planetary defense simulations alongside FEMA exercises designed to prepare for impact scenarios that could cross into national security territory. When those simulations run, every byte of data is tightly controlled. And that leads us to the next question, one that feels bigger than a technical glitch or a routine handover. Is it possible that certain discoveries don't reach NASA's public databases first, but go straight to the Pentagon? Let's be clear. NASA and the U.S. military work side by side when it comes to planetary defense. If they ever found something truly concerning, a fast-moving object on a potential collision path, or something they couldn't classify, the first step wouldn't be a press release. It would be a lockdown. Access restricted. Data rerouted. Eyes only. The real question is, what kind of discovery could force that kind of silence? Here's where the story starts to stretch beyond coincidence. NEOS wasn't the only system to go quiet right after detecting something strange. Over the past few years, there's been a pattern, a rhythm of silence that seems to follow every time NASA's instruments brush against the unexplained. In 2023, Voyager 1, the spacecraft that's been transmitting data from interstellar space for decades, suddenly began sending structured signals that engineers couldn't decode. The patterns looked like compressed data, too organized to be random static. Then, just as quickly as it started, the transmission stopped. NASA called it a telemetry glitch, but behind the scenes, technicians reportedly couldn't recreate the behavior in simulations. That same year, the James Webb Space Telescope, built to look deeper into the cosmos than anything before it, went into a sudden sensor blackout during what was supposed to be a routine calibration. The reason? Webb's instruments had accidentally locked onto a tiny asteroid orbiting between Mars and Jupiter. The system wasn't even supposed to detect objects that small. For several minutes, the sensors overloaded, then went dark. The official statement labeled it unexpected data noise. But once again, the event aligned with an unlogged, short-lived detection of an unidentified near-Earth object. Different instruments, different missions, same sequence. An anomaly appears. A system falters. A period of silence follows. When you map these shutdowns side by side, Voyager 1 in 2023, JWST in mid-2023, and NEOS in 2024, a pattern starts to form. Each incident begins with data that doesn't fit any known model and ends with a communications blackout. So, could NASA's detection systems be catching something they can't yet explain, and intentionally pausing to prevent false positives? Or worse, to keep potential panic in check? Because if these weren't ordinary asteroids, what were they? Start with the simplest and scariest possibility, the classified detection theory. A near-Earth object throws back an echo that doesn't behave. The radar return looks metallic. Parts of the signal ring hollow. That combo doesn't match a rubble pile. It suggests structure. It suggests cavities, maybe paneling, maybe tanks, maybe something built. Rather than spark chaos, the data gets locked. Engineers label the pause as maintenance. Externally, it reads like a planned shutdown. Internally, it's a containment window. Teams check the signal chain. They rerun calibrations. They compare with independent dishes. Nothing leaks until the echo is confirmed. Now, the second path, the planetary defense emergency theory. In 2024, NASA ran a high-stakes simulation. The scenario showed a 72% impact chance. The timeline stretched over years, not days. Some believe that drill wasn't just training, it was a dress rehearsal. The numbers came from a real detection. Not a hoax. Not a rumor. A preliminary solution that placed a rock on a worrying arc. If that's true, silence becomes strategy. You stabilize tracking. You build options. You coordinate deflection windows. You talk to allies. You don't broadcast half-baked vectors to the public. You wait until the core solution holds. Third, the unknown physics theory. We've seen non-gravitational pushes before. Oumuamua drifted without a visible jet. Light pressure, outgassing, exotic ices. Debate still rages. Now imagine a new object that breaks those models harder. Acceleration spikes, spin states flip, light curves jitter, the algorithms flag anomalies, the filters can't keep up. At that point, a shutdown can be a safety valve. You halt public streams. You prevent bad data from seeding panic. You reroute the pipeline. You bring in more eyes. You rebuild the model from the raw counts. Each theory fits the same facts: a strange detection, a short silence, a tidy explanation after. But the motives diverge. One points to engineered hardware. One points to an impact timetable. One points to physics we don't yet have. All three point to stakes that justify closed doors. And all three explain why the timing felt surgical. Here's the edge that keeps people up at night. If the echo was artificial, timelines compress. The window to study shrinks. Opportunity beats protocol. If it was an impact case, logistics rule, launch windows, deflection mass, and politics decide everything. If it was new physics, pride takes a backseat. You admit the model's broke. You rebuild in silence to avoid 1,000 loud wrong takes. Here's the number most people never hear: 98%. That's NASA's current estimate of how much of the large, potentially hazardous asteroid population we've actually found, which sounds impressive until you realize what the missing 2% means. That sliver of uncertainty hides hundreds of uncharted rocks, objects big enough to erase a city, maybe even tilt a climate, but faint enough to slip past our telescopes. They come in from angles the sensors can't cover, from the sunward side where blinding light blinds every infrared eye. 2% might sound small, but in cosmic terms it's a blindfold. Now think about timing again. NEOS goes dark right after spotting something strange, an object that crossed Earth's path and then disappeared from every tracking feed. What if that blip, the one that triggered the alert, was part of that missing 2%, large enough to matter but small enough to hide until it was almost too late? Imagine an object that size, half a kilometer wide, slipping through the detection net. It wouldn't need to hit Earth to cause chaos. Even a close pass could distort satellite orbits, scatter debris, jam communications. If that's the kind of object NEOS caught in its last hours, NASA wouldn't just be dealing with data, they'd be facing a clock. We may be missing not just one asteroid but the most important one. And if that's true, the shutdown wasn't the end of the story, it was just the beginning. If a detection ever showed an impact path near a populated region, you and I wouldn't hear about it right away. The first notifications wouldn't go to the news or social media, they'd go to national defense channels. That's how the system is designed. NASA identifies the object, flags the potential risk, and then hands it off to the Planetary Defense Coordination Office, which immediately loops in FEMA, the Pentagon, and international counterparts. In that moment, science takes a backseat to strategy. Analysts would start running evacuation models and impact simulations, calculating where debris would fall, how far the blast wave might travel, and which regions could be hit hardest. Governments would prepare quietly, waiting for certainty before releasing anything to the public. The last thing they'd want is a false alarm that triggers global panic. Picture the tension inside those rooms. Engineers triple-checking orbital data, officials weighing when to break the news. Somewhere, someone is staring at a trajectory that cuts too close to home. They'd have to decide, do we warn the world now or do we wait for confirmation? It's easy to imagine NASA's silence as secrecy. But maybe it's not about what they're hiding. Maybe it's about time to understand what's really coming, time to plan a response before it's too late. Long before the silence, NASA built its entire defense network around the idea that we could see danger coming. Programs like Pan-STARRS in Hawaii, the Catalina Sky Survey in Arizona, and Atlas, which now scans the sky from both hemispheres, are the eyes constantly sweeping the darkness for what we might have missed. Each night, thousands of new observations stream in, most of them harmless pieces of rock or dust. But every once in a while, one moves differently, faster, brighter, unpredictable. That's when it escalates to the next level. That level is NASA's Planetary Defense Coordination Office, the nerve center that decides what happens next. When an object crosses a certain threshold of probability, they're the ones who contact FEMA, who bring in the military, who decide whether to simulate an impact or prepare a real one. Their job isn't to panic the world, it's to buy time. And now, with NEOS gone, a new generation of detectors is waiting to take its place. The NEO Surveyor, launching around 2027, will be NASA's dedicated asteroid hunter, an infrared sentinel designed to find city killers, even when they hide in the glare of the sun. It's faster, smarter, and more sensitive than anything before it. For years, NASA has been the world's window to the cosmos, a beacon of scientific inquiry and discovery, meticulously documenting every mission, every experiment, and every celestial anomaly. Their commitment to transparency has been a cornerstone of public trust, making their recent silence all the more unsettling. While preparation for the unexpected is a core tenet of space exploration, preparation does not equate to obfuscation. A closer look at recent events suggests a pattern emerging, one that points not to mere coincidence, but to something far more profound and deliberately withheld. The pieces of this cosmic puzzle, when assembled, begin to form a picture that is increasingly difficult to dismiss. Consider the untimely shutdown of NEOS, a telescope specifically designed to detect near-Earth objects. Its sudden deactivation coincided with a period of heightened celestial activity, raising immediate questions about the true motivation behind its operational halt. Was it a technical malfunction, or was it a strategic move to limit public observation? Then there's the perplexing case of 3I divided by Atlas, an interstellar object that presented an unprecedented chemical signature: nickel and cyanide, but notably an absence of iron. This composition defies all known natural astrophysical processes. Such a unique and inexplicable elemental makeup should have been a focal point of intense scientific scrutiny and public discourse. Instead, its unusual properties were largely downplayed, if not outright ignored, by official channels. The scientific community grappled with the implications of an object that seemed to break the very rules of cosmic chemistry. Yet NASA offered little in the way of comprehensive explanation or sustained investigation. Adding to this growing list of anomalies are the unexplained pauses in other NASA data streams. Each of these interruptions mysteriously followed moments when something unexpected, something defying conventional understanding, appeared in the sky. These are not isolated incidents but recurring patterns suggesting a deliberate intervention rather than random technical glitches. In an age of advanced data processing and robust telemetry, such consistent and conveniently timed pauses are cause for serious concern. It is tempting to attribute these occurrences to mere coincidence, to the unpredictable nature of data collection in the vastness of space. Perhaps instruments malfunction or cosmic phenomena interfere with transmissions. However, the cumulative weight of these incidents makes such explanations increasingly implausible. The most striking and undeniable fact remains: NASA's period of unprecedented silence directly followed a discovery that fundamentally challenged our understanding of asteroids, and by extension, the very fabric of our solar system. Imagine a global institution built on the principles of constant observation and open dissemination of information suddenly plunging into an information vacuum. The same agency that meticulously publishes every minute detail of its missions, from the smallest dust particle on a rover to the grandest stellar explosion, abruptly ceases communication after encountering an object that shattered every preconceived notion. This is not the behavior of an organization simply processing complex data. It is the action of an entity grappling with something so extraordinary, so potentially paradigm-shifting, that it felt compelled to pull the plug on public disclosure. Was it truly just another rock, albeit an unusual one? Or did NASA witness something so profoundly extraordinary, so utterly outside the realm of established scientific understanding, that the implications for humanity were deemed too significant, too destabilizing for immediate public consumption? The possibility exists that they encountered evidence of something truly unprecedented, perhaps even intelligent, which necessitated an immediate and complete blackout of information. The story, by all accounts, is far from over. The lingering questions, the unexplained anomalies, and the profound silence from an organization usually brimming with information all point to a deeper narrative waiting to be uncovered. To truly understand what NASA isn't saying, one must remain vigilant and critically examine the gaps in the official narrative. The cosmos holds secrets, and it appears some of them are being held very tightly indeed.